Hi, in this video I'm going to talk about boundary conditions, meaning that there are some problems where we have to calculate the integral of a certain function, and then it's given a condition such that you can find a real value for the constant c that you add in your result of the integration. So sometimes an extra condition, of the form f of a equal b is given in order to find the constant c. We can see here some examples. Let's say that I have an exercise that is telling me that f prime of x is equal to 3x squared plus 2x, and that f of 2 is equal to minus 3. And it tells me to find f of x. Well, the first thing I have to do, right, since I have f prime, it's to integrate this function over here. So I integrate 3x squared plus 2x in the x, and I find my antiderivative, which is the function f of x. And I know that this is equal to the integral of 3, that I can put out, it's a constant, the integral of x squared in the x, plus 2, the integral of x in the x. And therefore I know that this gives me 3 times x to the power of 3 divided by 3 plus a 2 times x squared divided by 2. And then I can simplify here, but I know here that I have left a constant c, where c belongs to r, the real numbers, right? So I know that my result is, in general, actually I can rewrite it in a better way, x cubed plus x squared plus c. Now I know that f of 2 is equal to minus 3. So what I'm going to use, it's exactly this result. This is f of x. So f of x is equal to x cubed plus x squared plus c. So I know that f of 2 is equal to 2 to the power of 3 plus 2 to the power of 2 plus c, and this is equal to minus 3, which is given. Therefore, this means that I have the equation 8 plus 2 to the power of 2 is 4 plus c, which is equal to minus 3. And therefore, I know that c is equal, after some arithmetics, to minus 15. Let's see another example. Let's say that we are given a rate of growth of a population. And this rate of growth is given by the formula dp over dt equal 150 square root of t. First of all, what this means? This means simply that p of t prime, it's equal to 150 square root of t. These are equivalent notation, okay? This is a function of time because the population of fish, it's actually behaving, the rate of growth, it's actually behaving this way, but we don't know, okay, what's the population in terms of time, so as function of time. But we can find it through integration. So integration is actually the tool here that provides p of t. So p of t here is the integral of what? Exactly of the function given above, which is the rate of change in dt. So if I perform and I rewrite this integral, I can move out the constant. I can rewrite the square root as a power, t to the power of half. And therefore I can solve my integral in the usual way. So this is a power, so this becomes t to the power of half plus 1, which is 3/3, divided by 3 and a half, and this is also 3 divided by 2, right? So this is going to be 2 times 150 divided by 3 times t to the power of 3 over 2. So this means that actually I can write down this as 100 times t to the power of 3.5 plus a generic constant. So actually I have to add it here, where the constant, as we know very well, it's belonging to the real numbers. But what if in the problem it's telling me that the initial population was 200 fish? Well, it means that I will have a condition for the original time, right? So the time equals 0 equal to 100. And then in this case, of course, I can find out what's C. So in this case, of course, I have to put to 0 t. So let me rewrite here what was the function. P of t was equal to 100 times t to the power of 3.5 plus c. And therefore, in 0, p of 0, which is equal to 200, it's going to be equal to 100 times t to the power of, which is 0, sorry, so 0 to the power of 3.5, which is still 0, plus c. So it means just that c is equal to 200. And my final function is going to be 100 times t to the power of 3.5 plus 200.